Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hommick's Middle School Earth Science Department. Today we're going to be talking about relative humidity and dew point. Now the great thing about these two factors in weather is that they help us measure the moisture in the atmosphere. So what we're going to do is we're going to start actually talking about dew point, then we're going to jump into relative humidity. So let's get started. Dew point is kind of a neat phenomenon because it tells us when the air is saturated. It's the temperature in which the air is going to be completely filled up with moisture. And that's what that word saturated means. At that specific temperature, that dew point temperature, precipitation, condensation, clouds, it's going to be very evident that there's going to be a lot of moisture in the air, very simply by looking at the clues outside. Now when you talk about saturated, think about a sponge. Sponge filled up in a bucket of water, that sponge is going to soak up as much water as it can. That's what the word saturated means. Well, in nature, you want to look for clouds. Clouds and precipitation are going to be a telltale sign that air is saturated. You can tell that the air has a lot of moisture in it even in the summertime. You take out a cold glass of soda out of the refrigerator, and what's going to happen is you're going to get little beads of sweat on the outside of that glass. Well, the air touching that cold glass has cooled to what we call the dew point. Now, air temperature and dew point, they have a nice little relationship with each other. When they're close together, and in many cases when they're equal, we know precipitation is going to occur. We say the air is saturated and the humidity outside is going to be close to 100%. When they're really far apart, it means you have beautiful clear skies. You don't have a lot of moisture in the atmosphere. The air tends to be extremely dry. Well, the map on the left, current temperature in South Dakota is 33 degrees. The dew point in the same location is 33 degrees. You're going to have a good chance for rain. Look in New York, is 56 degrees outside, 27 dew point. You talk about a 30-degree difference there. You probably have beautifully clear skies on this day along the East Coast. Well, your relative humidity is the amount of moisture that the air is holding at a specific temperature. Cold air has a very different capacity to hold moisture than warm air does. We'll explain why that is a little bit later on. When you talk about humidity, humidity is always a percentage. So anytime you see a humidity percentage, always try to think about a glass of water filled up to that percentage. If the humidity outside is 97%, if I had a glass of water filled 97%, I'd have a lot of moisture. If I had a humidity outside that's 27% and I had a glass of water filled up 27%, I know I don't have a lot of moisture. So that little analogy will give you an idea about when you have a lot of moisture compared to when you have very little moisture in the atmosphere. So cold air, the reason why cold air doesn't have a whole lot of room for moisture to work its way into is because cold air contracts. So those molecules get squeezed close together, they become very tightly packed together, very densely packed, which means that the air is going to sink. Dry air is usually going to be found associated with colder temperatures because there's just not a lot of room for water vapor to work its way into. And the water vapor that does work its way into cold air fills up extremely quickly. Well, you compare that with warm air expands, ton of room for moisture to work its way into. Because those molecules expand so far apart, the air becomes has an extremely low density, which causes that air to rise up. Not to mention that water vapor actually weighs less than air molecules, so water vapor is going to cause that warm air to rise up as well. Greater capacity to hold moisture than cold air. That's why you feel the 100% humidity in the summertime. You say that it's hazy, hot, and humid outside. You don't feel it in the wintertime because 100% humidity in the wintertime is not a lot of moisture. 100% humidity in the summertime is a lot of moisture. So I kind of give that analogy of the warm air being the big beaker, cold air being the smaller beaker. Both have the same size water droplets in it. In the big beaker, it's only filling up about 20%. In the small beaker, it's filling up almost 100%. Same quantity of water, just different temperatures. Cold air mass, the smaller beaker, gets filled up much quicker than the bigger beaker, which is your warm air mass. You see here with the different circles. The red circle just represents the warm air. Those molecules are really spread far apart. You can squeeze a lot of water vapor into that red circle. The cold air mass, the blue circle, is already pretty much filled up. And when you compare the two water contents, the warmer air mass is going to be able to fill in a lot more moisture than the cold air mass. You see the two maps? You see the big low pressure center with all the precipitation in the center of the country. Look at where the key is with the relative humidity. Again, it's close to 100%. Anytime you get 100% humidity outside, you're going to probably have a pretty saturated air mass. You're probably going to get some rain in that case. You have your two curves here. Relative humidity is the solid line. Air temperature is the dotted line. When humidity goes up, temperature goes down. That's going to occur at about 6 in the morning. When temperature goes up, humidity goes down, that's going to occur at about 4 o'clock in the afternoon. Well, what do we know about the relationship between relative humidity and air temperature? They are indirect. Temperature goes up, humidity goes down because warm air expands. Humidity goes up when temperature goes down because cold air contracts. So definitely know the difference in regards to the different times of day when the humidity is going to be highest and when humidities are going to be the lowest. There are two ways in which you can change the moisture content within the air mass. One way is keep a constant temperature. The second way is to increase or decrease the temperature. So you're going to change it. Let me show you. Constant temperature, 92 degrees. Well, that doesn't really occur outside too much, but inside your home or inside your apartment, you can regulate the temperature. You can keep it at a constant temperature really throughout the entire day. So if you keep a constant air mass at about 92 degrees, well, at 6 o'clock in the morning, that air mass is only taking up about maybe 20% humidity. But you keep pumping water vapor into the atmosphere through, say, a couple of humidifiers, by 12 o'clock, that air mass is going to be holding maybe about 60% humidity. By about 6 o'clock in the evening, it might be holding upwards of 100% humidity. Constant temperature, you just keep pumping more and more water vapor into the atmosphere. The analogy that's a little bit more consistent with what happens outside is taking an air mass of, say, 91 degrees, which is holding maybe about 20% humidity, and cooling it to about 47 degrees. Well, it's the same quantity of water vapor, it's just that the air mass has contracted because cold air contracts. Now that beaker is holding about 50% humidity because you have significantly less room. So definitely know the difference between relative humidity and dew point. I have a whole podcast on how to use the two charts in your reference table, so please check them out as well. So other than that, thanks for joining me, and we'll talk to you soon.